Le Chatelier principle. Le Chatelier principle says if a reaction is at equilibrium, then whatever change we do, reaction proceeds in a direction to cancel that change, right? So what does that mean? That means if you increase, reaction wants to remain at equilibrium. Reaction is at equilibrium, reaction wants to remain at equilibrium. If you add reactant, reaction wants to finish that reactant and reach the original position, right? It wants to maintain the equilibrium constant, that it wants to be at equilibrium. So if you add reactant, then what happens? Reaction moves forward to finish off that reactant. So reaction will move forward to gain equilibrium back. If you add product, reaction moves backward to finish off that product or to reach a equilibrium state, so that ratio of product upon reactant remains as it was earlier. All right. If you add reactant, moves forward. If you add product, moves backward. If you remove product, that means product becomes less. So reaction keeps moving forward. All right. So this is the concentration change effect on the equilibrium condition. And if you have a temperature change, what happens? If reaction is exothermic, if reaction is exothermic, on increasing temperature, reaction moves backward. If reaction is endothermic, on increasing temperature, reaction moves forward. All right. So I'll repeat it again. If reaction is endothermic, on increasing temperature, reaction moves forward. Or if reaction is exothermic, you increase temperature, reaction moves backward. All right. And next is addition of catalyst. What does that do? If reaction is at equilibrium, that means rate of forward equals to rate of backward. If you add catalyst, rate of forward increases, so as rate of backward. Both increase. So again, they are equal after certain time. So no effect on equilibrium on adding catalyst. So catalyst has no effect. Now next is pressure change. So if you change pressure, so reaction wants to reduce the pressure. So which direction it will go? On increasing pressure, reaction wants to reduce the pressure. So it will go in the direction where number of gaseous moles is less. If you decrease pressure, what will happen? It wants to increase pressure. Whatever we do, reaction wants to do the opposite. If you increase pressure, it moves in the direction of less number of gaseous moles. If you decrease pressure, it wants to in, go in the direction of increase in number of gaseous moles. All right. Or and what else you have? Sometimes you have equal number of gaseous moles on reactant and product side both. For example, this one H2 plus I2, there are total 2 moles out here and we have 2 moles on the product side. So we have 2 moles on the reactant side and so as 2 moles on the product side. So what happens is you have 2 moles out here and 2 moles out here. So on changing pressure, there is no effect on the equilibrium of this reaction. So if delta Ng is equals to 0, no effect of pressure. If delta Ng is greater than 0 or delta Ng is less than 0, then we do have effect of pressure on the reaction. All right. For example, if we increase pressure out here, so what do you see? If we increase pressure, then reaction moves forward. If we increase pressure in this reaction, below reaction, no effect out here, right? So we have explained the things over here, and here we have example in which process is endothermic. If you increase temperature, reaction moves forward. And in this example, we have process exothermic. What happens? Increased temperature, reaction moves backward. Here, endothermic, reaction moves forward. Here, exothermic, reaction moves backward. So these are the things which affect equilibrium condition, not the equilibrium constant. Be careful. Equilibrium condition can be affected but not the equilibrium constant, because if condition is affected, equilibrium condition is affected, that means there is no more equilibrium, then the ratio will be known as reaction quotient, not equilibrium constant. Again, after some time when equilibrium is reached, then we take the ratio of product upon reactant as equilibrium constant. So equilibrium constant will always be constant for a given reaction. It will not change by any of these conditions. What changes? Equilibrium state. For time being, it changes and it will revert back to equilibrium condition. All right. So these are the things we have over here for now.